All of you? So the velocity of a sound in air increases by approximately 0.61 meter per second for 1 degree Celsius rise in its temperature. Means now, initially we all know
For
that
every 1 degree Celsius,
yes, by a
it
factor of
approximately increases
0.61. By a
0.61
factor of
meter per second.
0.61, Mari, that's all. Understand?
Yes, sir.
Yeah. So now imagine at 0 degrees Celsius, we got it 331 meter per second. Now at 22 degrees Celsius, I want to calculate. I don't know current. So let us calculate now. So what is the T is equals to now? Speak loudly, everybody. What is the T is equals to? T naught. T naught already we know that. Yes, please. Velocity temperature is what? 0 degrees Celsius. Now VT, sorry. Yeah, V naught. V naught at 0 degrees Celsius, how much it is? 331 meter per second. Am I right or wrong? Please respond, guys. Yes. Now VT is equals to how much? I will take 22 degrees Celsius. So let us see how much is the velocity. So velocity at 22 degrees Celsius is equals to V naught at 0 degrees Celsius. V naught at 0 degrees Celsius 1 plus T divided by 546. So let us make it now. V naught is equals to 331. 1 plus T. What is the T value? How much? How much, guys? 240, 22 divided by 246. You all should solve. Sanjay, are you there in the meeting? I want response, Sanjay. So make it everybody clearly. So this is what it is, which is equals to 331. Here I will take LCM as a 546. 546 plus 22 divided by 546. Multiply it and make it fast. Tell me everybody, girls. 546 plus 22, how much? 546 plus 22.
556.
568. 568 divided by 546. I'm giving 1 minute time. I want division. Let me see who will say first. Division, please. 568 divided by 546. Answer, Nivedan. This much slow means how it is. People has to like speed up, everybody. Abhirami, no response. And many people, Karthik, this what is this? Kishore, Mugesh, Prardhana, Prithvi, Sam, understand Sam? Princey, that's what. What is the answer? 568
Yes, sir.
by 546. Yes, okay. Division, tell me. 1 point. Anybody?
1.0.
1.0, you must solve. You must solve. Not using calculator and all not. Okay. So you must solve, everybody. That is what is my expectation. So 1.0402 something it will go. So let it be. So I'll stop it here. 029. So multiply this both and tell me how much it will come. 331 into that. Exactly you will get it. You can see 344.3333 something it will goes. 3369 and all. So at 22 degrees Celsius, what is the speed? We all knows that. Can you verify and tell me what is a given book? Given book how much, guys?
44.
344.
Ellame answer got it? Yes or no? Even you can multiply
Yes, sir.
the 1.1.04. You will get approximately 344.24. 344.24, which is approximately, which is equals to 344 meter per second. This is the formula. Now, let them give a temperature at any temperature, you can find the speed of sound in air. Am I right? This is the formula for it. Okay, guys? All of you? Is it interesting, Mr. Sam? I want to answer, Sam. That's what. So what is the formula, everybody? V naught is the velocity at 0 degrees Celsius. And you can find the velocity of a sound in air at, let them give at any temperature. This is the formula. You can use it and you can find it. I hope you all understand. You want to find it now for 25 degrees Celsius, you can find it. So you'll get it approximately 346. Am I right or wrong? You can verify and let me know. Nirosh is solving. Nivedan, Mugesh. I don't know. Many people are not all solving. Where is Agalya and Shivani? Shivani is there. Okay, do it. Agalya, finished, Amma? That's all. Okay. Any
So
doubt?
one doubt.
Yes, what?
So velocity is equal to
Yeah. Tell me.
Velocity is equal to constant into root over time, sir. Sorry, root over temperature, sir.
Hmm.
So how can I find the value of K, sir? As it is
That's
constant.
what I'm saying. That constant value they will give you, but that is for one temperature. You understand? For one particular temperature, if you want to find it, that is what. Are you clear?
Yes, sir.
Now you no need to worry about the temperature at all because already we have found the relation. At 0 degrees Celsius, already they have given you the temperature. You no need to worry about it. You understand, Mari?
Yes, sir.
So now your duty is to find the speed of a sound in at any other temperatures. So at any other temperature, you are already having expression, correct?
Yes, sir.
So further, that's all. You no need to worry about it. Clear?
Okay, sir.
Let them give any temperature. You can find it now because you know at 0 degrees Celsius 331. Let them ask at 50 degrees or 100 degrees or 200 degrees. It doesn't matter for us. We can find the sound. Clear?
Yes, sir.
Yeah. That's what it is. Clear, everybody? Now the most important and interesting concept, that is what we are going to discuss, Doppler effect. So if you till here you understand, everybody, I hope you all clear. Agalya, Shivani, understand? Kavya, that's what. So now we are going with the next concept, that is what is that Doppler effect. So this is also the most important and interesting one, which we will experience in daily life. So, how many of you traveled in train till now? Railway platforms, at least. Have you all experienced it? Anybody? Is there anyone who not a travel in train, at least in railway station? I hope I don't. So everybody has some experience. Is it right? Will you all agree with me, guys? Answer, please.
Yes, sir.
Yeah. So let us comes to here. So what is the link between them? Doppler effect is we can experience it in a train. So next time when you go to the railway platform, you all can see that. So imagine that when you are waiting in Pudukkottai railway station, like for waiting for a train, whatever it is, going to Chennai or going to Trichy or some XYZ places. So you can see that when train approaches a station, you can see at a high speed, and high speed as well as it is blowing the horn. Particularly you see the train which not stop in a particular station, it will go with the what? High speed and with the continuous blowing horn. Will you all experience it, everybody? The train which will stop, it will come slowly and it will blow the horn. But the train which will leaves, like a goods train or Vande Bharat Express or something, which will not going to stop in the normal platforms. I'm saying you that. Do you all understand, everybody? Yes, please. Answer, guys.
Yes, sir.
Yes. So now, when a train approaches a station at high speed while blowing the horn, suppose imagine you are the person who is standing on the platform. So the frequency of the horn would appear to be different from the real frequency. When the train is keep on fastly moving with continuously blowing horn. Next time you experience it. But here, what is the reason, sir? The pitch of the sound appears to be increases. Pitch is directly proportional to what? We all knows that. We already studied. Pitch is directly proportional to what?
Frequency.
Frequency. So, suppose I am a person who is standing on the platform. Now the train is going on a track. Very high fast. No stopping at all. Very highly continuous blowing it is going. Blowing. And it is moving. So then the frequency of the horn is appears to be very high because the pitch is appears to be increases with the train approaches an observer. So I am an observer who is standing. So when the train is approaching with high velocity or high speed and continuously blowing, so the sound is appears to be a high pitch sound because of frequency keep on increases. Pitch increases, frequency increases. Now, you can see when the train is approaches an observer, you can now same way, it appears to be lower than its true pitch when the train passes by and moves away from the observer. So that is you have to remember. Okay. When the train is approaching with a high speed and blowing horn, it is appears to be high frequency. And when the train passes him, means it crossed him. When it is crosses, it is going far away from him, far away from him. Then it is appears to be low pitch. The pitch, when the train decreases, lower the pitch or lower the frequency, when the train passes, moves away from the observer. Similarly, while traveling a vehicle, like you can see, while traveling in a vehicle towards to a factory, imagine there is a factory where siren. Have you noticed it? The shift and all, whenever the shift completed in factories and all, they'll put a siren. Am I right, everyone? Yes, please. You will say only, I will answer. Otherwise, I cannot. Response, guys. Factories
Yes,
and
sir.
all after shift timing. Shift timing, they'll put a siren for all the labors and all, they will go. Do I remember everybody? The same thing. So imagine you are traveling in a vehicle towards a factory, like towards a factory blowing the siren. So changes in the frequency of the sound produces can be observed. So you can observe the variable frequencies of the same horn sound. So that is the phenomena, like we can say, the phenomena of apparent changes in the frequency of a sound whenever there is a relative motion between the source of a sound and the observer. That is what we used to call it as Doppler effect. So that is what, when it is a relative motion, you will be feeling a different pitch. I will explain it more deeper. And when it is passing away, like one is moving and another one is passing, then it will be different. So let us see now. That is only call it as Doppler effect. So let us define the Doppler effect and we can make it. Right. The phenomena of apparent changes in the frequency. Sanjay, are you clear, Sanjay? The phenomena of the phenomena
Right,
of
sir.
the phenomena of the phenomena of apparent change in change in the apparent change in the frequency of a sound whenever there is a relative motion, whenever there is a relative motion between the source of sound and the observer is called Doppler effect. Sam, are you there in the meeting? Prithvi? Okay.
Sir.
So that is what. So you can consider it like you can take, consider a train in the case of source of a sound. Consider a train. If I consider a train, so you can see train is coming towards to you, you are in a platform. That is what I'll consider a source of sound. A train is a source of sound because blowing horn at S1 distance, moving with a uniform velocity. Let me consider Vs and towards the observer O. So where the person is standing. So imagine there is a platform. I'm taking directly. So observer is O, who is the observer. Okay. Now, initially train is at a particular point. That is what I consider train at S1. Initially, S1. So after certain time, it will come near to him. Let me take that point is S2. So then it will be different things. It is coming towards to us, approaching us. Now, if you notice it here, moving with a uniform velocity, Vs. What is the velocity of the train? Everybody? What is the velocity of the train? All of you. Vs, uniform velocity. So, velocity, we all knows that. So, distance traveled by that. Normally, what is the speed formula? Speed is equals to distance by time. Now, distance is equals to what? Velocity into, speak guys,
Time.
velocity into time. Same thing. So, I am taking consider a train at source S1 and moving with a uniform velocity. Uniform velocity Vs, and time period you can take it as a T. Time period T means the train came from S1 to S2. Then what is the distance travel? Distance travel is equals to Vs into T. Will you all agree with me? Everybody? I want response from the people. Yes, please.
Okay.
Yes. So now, let V be the velocity of a sound and lambda be the wavelength. So we all knows that. So you can consider that T is the time period of a sound wave. So the time interval between the two waves, the generations, like we can see is when is yes, here focus rare. So if you all notice it, all of you, when is at S1, you can see it may produces the distance is different, and when it is travel from S1 to S2, it may the difference distance is different. So what will happen when it is approaching a person? When it is approaching a person, the train with the fast and blowing horn. So I am saying that the frequencies appears to be what? Higher, lower? Frequency of a sound. Everybody, frequency of a sound increases. When it will cross, again the frequency of a sound, what will happen? All of you. Frequency of a sound, please respond. Everybody. Decreases. So when the train approaching to the observer, the frequency of a sound appears to be increasing, and when the train passes the observer, the frequency of the sound appears to be decreasing. So that is the effect which we used to call it as, what we used to say, all of you. Yes, please.
Doppler.
Change it. Doppler effect. So this is what we used to relative motion. So here observer is at constant, train is moving. But in the case of like industry siren, what is happening? We are approaching, and horn is that what is that? Industry siren is coming from the same place. Am I right or wrong? Everybody, please respond. All of you. So factory blowing the siren. So the siren of a factory is coming from the particular place. Now I am traveling in a car. What will happen? I am approaching to the siren. So initially at S1 distance, after that S2 distance, so that I am traveling with a uniform velocity, so that it will take a certain time. So when I reaches from S1 to S2, you can see that. So then the frequency of the sound waves is varies. So here relative motion. Here train is moving with respect to the observer, and here person is moving with respect to the source of sound. So that is what we used to call it as relative motion. I hope you all understand. So based upon the phenomena of apparent change in the frequency of a sound, whenever there is a relative motion between the source of sound and the observer, is only call it as Doppler effect. Is it okay, guys? All of you? Yes, please.
Yes, sir.
I want response. So that is what you have to make it. So this is what is the concept of Doppler effect. So if you understand it, it's fine. So next, if you are clear, we'll continue from here in the next class. Now, so you might be remember, I have taught you there is a concept called it as sonic boom. How many of you remember a sonic boom? A sonic boom.
Yes.
Yes, sir. Anybody definition, please? Sonic boom. Sonic boom. Sonic boom. Yes, please. I want definition for sonic boom. And example also I told you. What is the example for sonic boom we can consider? Anybody?
Fighter jets.
Fighter jets. Another thing. During lightning, something will can be heard. Anybody?
Thunder.
Thunder. So when we can say is the speed of sound is, yeah, supersonic jets. Very good, Sanjay. So the speed of object is more than the speed of sound in air. That is called as sonic boom. Am I right or wrong? Everybody? Yes or no, guys?
Yes, sir.
Yes. So, but of course, that is based upon, that is only called it as sonic boom. So sonic boom is based upon the Mach number. So bullet trains, you might be heard it. Do you all remember, everybody, bullet trains? So there is a train in Japan, actually. So Japanese train. So this Japanese train will travel with a 574.8 kilometer per hour. Means 160 meter per second. This is the fastest train in the world. So this is the sound produced by this is the what sound? Anybody? It is the, what is the train? It is a sonic boom. Am I right or wrong? All of you. Yes or no? It is
Yes.
traveling faster than the object. Am I right, guys? Sorry, speed of sound. What is the speed of sound? 340 meter per second. But the train is traveling, you can see, it is traveling very highest speed. Like generally you can take in kilometer per hour. So the Japanese train, the name, even the name, this is for general knowledge I am saying. The Japanese train name call it as a maglev. Maglev is the bullet train, which is the fastest train in the world. It is the speeds in its range actually. So this is what. So you can take here any kind of object. Generally, if it will travel like faster than the speed of sound in air, that is what we used to call it as sonic boom. So we can decide this sonic boom with the help of a Mach number. So that what is that Mach number, how to calculate, that is all I'll teach you. So what is the sonic boom? Everything with the help of figures we'll discuss in the tomorrow's class. And then tomorrow we are going to discuss one more thing. That is what we can say is, like as I told you, frequency of a fundamental mode. I told you correct, lambda to for stationary waves, and that is all. So that is all we'll discuss in the tomorrow's class. The formation of stationary wave along a stretched string. So how to form and all. Okay. So this is what about it. I hope today have you learned everybody anything interesting, all of you.
Yes.
Tomorrow, based
Yes, sir.
upon like law of vibrations of a structured string, if you make it, so based upon what it is depends and how to make it. Because 12th class you will get it a instrument, call it as sonometer. So sonometer is based upon the sound only. Okay. I think 11th class only, 11th or 12th you will get it exactly. 11th only, my guess is true, but 12th class you will do the practicals. So sonometer is based upon the we can say it's like vibrations of a structured string, like a guitar, sitar. You all knows that everything is based upon the principle only. So that is what we'll see in the tomorrow's class. So after that, of course, all the applications we studied, and then we'll go to the, I think almost it's came. So only 1 week time. I think 29th you have a math exam. Am I right, everybody? Yes,
Yes,
please.
sir.
Yeah, so we'll
Yes, sir.
finish. As soon as we finish, we'll make it. Okay, so with this, I'll stop. I hope you all learned anything today, everything, everybody. So we'll meet from here. We'll continue in tomorrow's class. Thank you, everybody.